What's up guys? I thought I'd make a quick video about my latest project which I just finished. It's an LED dragon you control with your phone, and I call him Pulsar. The dragon was made to carry around a music festival called EDC, which is in Las Vegas. They let you bring in signs and props and they call them totems. After the first time I went, I immediately had a couple ideas for a totem and landed on a dragon that would perch at the end of a pole. I started out by deciding whether to 3D model the dragon myself or find one online. I found one pretty quickly actually from an artist called BFPF who had generously put the files up for everybody to use. The files were in Pepakura format, which is a program for paper crafting. Pepakura takes in a 3D polygon model and outputs an unfolded flat version of that model that can be cut and folded out of paper back into 3D. I wanted to get a rough idea of kind of what I was dealing with, so I did a few of the parts in paper first, and I decided I liked the shape and I think I just needed to scale it up, so I went with it. This thing was going to be held while dancing and was generally going to get shaken around a lot, so I decided to make it out of foam and not anything rigid. I got this craft foam from Michaels and printed out the Pepakura files on 11x17 to cut out. From there, it was just a ton of cutting and gluing. I cut the paper pieces out with an Xacto knife and then taped them on top of the foam, which I then cut out again. Then I scored the foam along the fold lines that Pepakura instructed and hot glued the glue seams from Pepakura too. The cutting and gluing process took about a month off and on, but I actually found it pretty relaxing and usually just had a podcast or Netflix playing in the background. After all the foam had been cut, I started working on the skeleton and the back spikes. The skeleton is just a coat hanger wire glued along the body to give some rigidity, and the spikes contained LEDs to light up in sequence. I designed the spikes in 3D using Rhino and then printed them out in clear PLA plastic. They had these little rudders I glued on them so that they could grip the body well and have more surface to stick to on the foam. The LEDs were cut from a long strip of Adafruit NeoPixels and then extended between each one to the length of the spikes. These are the mini skinny size. Then I just glued the LEDs to the spikes and glued those spikes inside the body. Next up was electronics and software. I used an Arduino-based Adafruit Pro Trinket microcontroller and a popular LED control library called FastLED. I prototyped the hardware on a breadboard first and then soldered it to a more permanent protoboard. There's also an Adafruit Bluetooth chip to be able to control the animations remotely. The software wasn't too complicated since both FastLED and Adafruit had lots of example LED and Bluetooth control code. I had a bunch of animations and command interface for Bluetooth over UART. Originally I had planned to develop my own mobile app to control the commands, but as the deadline approached I decided it would be much easier to just use the sample control app that Adafruit developed called Bluefruit and send the commands over text. All that was left to do after that was 3D design and print a battery mount, paint, and assemble. This is the battery for the dragon. It's a 12-volt drill battery that plugs into a dock that outputs 5-volt USB. The battery lasts 6 to 8 hours depending on the animation, and I had two so I never ran out of power during the festival. Okay, so I wanted to give a quick demo of how everything works together and how you use the whole thing. So you open up the Adafruit Bluefruit app and go to the Bluetooth UART screen, you give it a help command, and it'll give you a list of all the commands that you can do. It starts out with a default command which just has like a rainbow that cycles slowly, but I give it a color pile animation which just fills up the LEDs top to bottom and then cycles them all clear. Then I set a max brightness of 255. There are a couple global variables that you can set and all the animations will use them, so max brightness will turn up all the LEDs brightness at the same time. We'll try the equalizer animation, which takes the global BPM variable and will pulse the whole tail to that variable. A couple of the animations use the global BPM variable for that kind of thing. And then there are a few more animations, but when you're done you just hit off and all the LEDs turn off. So that's a Pulsar. It was a little more labor intensive than I anticipated, but I'm pretty happy with how it turned out. If you have any questions, feel free to leave a comment. Thanks.